I'm always asking myself why there are many videos about software that seems to be like a tutorial, but in reality is someone designing a part, but they're not uh, recording any voiceover or anything like that explaining what is happening. I don't like that kind of videos. So this is a rare video, to be honest. I like more to go through tutorials and stuff like that, but let's take a look to this one. This is a reverse engineering of transformer toy. This is the leg. So I'm using solid edge, and this in real life, let's say I'm actually with the video on fast forward, let's say speed up. In real life took 1 hour and 30 minutes. So it's it sounds like a lot, to be honest. At the beginning I thought that this should take less time, but at the end, if you want to make something that is precise and is going to be exact replica of your model, well, you have to invest time in the details. Anyhow, the part itself is made out of aluminum. It's not cast, it's injected aluminum. It is clearly that because it is precise and it is also having a nice finish. Sand casting molds readily are uh, you rarely are going to have this quality of part. And of course, this is a toy and probably it is mass produced. And yeah, so the dimensions were easy to take. The model itself was clearly made for that. And since this is a request and I do not have the actual parts that fits with it, um, I cannot take the chance of taking the decision of filling some areas, adding materials on some areas, and then find out that it was not possible to assemble because the extra material that I, I included for the 3D print, let's say, adding some features may help us to 3D print the part better or easier without having troubles. But yeah, time to time it has to be that way. Um, so as you can see, I did the main geometry. Then I am starting to work on the internal features, and there are some shell thin walls on this part. I did some combination of solid modeling, also working with surfacing, some practices that um, at least from me, in my experience, it was clear that those geometries had been done using those techniques. Okay, so yeah, there are also some extra walls there are some rules that I try to follow, like do not add material that is going to be removed in the future. So this last uh, area or a material that I added is one of those breaking rules situations. So as you can see, there used to be a shell of the main geometry. Then I removed the material and then added back with a different feature sketch and all that. So these avoidance cuts are part of the things that I was considering as those adding material for remove later. But yeah, I was at the beginning of the job. It had been quoted considering just 1 hour of design. So I was, let's say, on a kind of a hurry, trying to get a quality part but at the same time I was not relaxed doing the thing because I don't want it to exceed the hour that I charge for this. So that takes me to the other topic, that is how cat in reality should be charged. So in my experience is basically people per hour and upward, and it is hard when you give a price for something, a fixed price, and then you find out that you were requiring more time and you spent a lot of time. So um, that's kind of awful situation. So I prefer to work hourly, to be honest. This is a rare thing because you say, come on, it's just a reverse engineering of the part. It doesn't seem like it's going to take that long, and you take the chance. But when we are talking about development or research, there there are many variables that probably you want to control, but it is hard to control. So at the end, you end up investing a lot of time. That's where hourly price is the best way to go. Okay, so I did a good effort and a good job, I would say, locating those feature holes because the part is not prismatic. Um, let's say it's not having a clear corner from where you can take dimensions to locate the center of those holes. So I had to do some tricks like measuring in between them, trying to do a triangulation, let's say, in between the three holes till finally get something that is going to be acceptable. The client sent me a picture that I'm not going to show in here of the transformer assembled, and it fits well. So if the customer is happy, I'm happy too. So um, this part, I believe it could be beautifully printed in resin or other 3D printing technology than FDM, but FDM is what I have in here, and well, I have a Bamboo Lab printer, which is awesome. Is awesome. So it did a good job at the end. It was more than acceptable. It was pretty good, and also that the fact that I took the measurements and did the 3D model, and in this case, I have not considered tolerances. So uh, the 3D model went to the 3D printer with the dimensions that I took, and the 3D printing was good enough for being acceptable to get assembled. So I cannot complain at all. So in here is one nice example where I used the surfacing technique. For example, I was needing to make this corner, but using just chamfers was not providing the exact same offset that the part has constantly around the corner. So I did some techniques of just adding references, extruded uh, lines, so they are just a face, and extrude them with the right angle, well, with exact angle, and keeping the offset that which was the concern in here. So you will see in a bit what I'm talking about. There you go. I can't believe this video is shrink to just 10 minutes, and it took me 1 hour and 30 minutes. But yeah, I, which by the way, I was also speaking while designing, but 1 hour and 30 minutes of me talking, wow, so boring. This thing could be boring by itself. If you're already still watching, you're probably wondering what. Okay, so there you go. I did a cutout with the surface. So in Solid Edge it is a boolean, a cut. So it is pretty close to the fashion of AutoCAD in 3D. But there you go. There are the two parts. The left one is the original one. The one at the right is the 3D printed one. So it's looking well. I did some modifications on the internals, but in general terms, it looks right. Yeah, I like the result. So now that if you are in here, you maybe are probably interested in some CAD tutorials. So here are some of them. SolidWorks, yeah, why not? Are you using Solid Edge? SolidWorks is going to be good for you too.